because we'll start off SQLite 3 with just enough database theory for you to understand whatever comes next. So here's a screenshot of a small section within a CSV file. This could also be your Excel file, right? So here there are totally 5 rows. That is, there are 5 students. Let's call this Excel sheet a table and let it be named as student info. As previously discussed, there are 5 rows and 4 columns. The column names are student ID, first name, last name, and contact number. There are 2 rows with the same first name, Vikram and Vikram, that is students with ID 2 and 4. 2 rows have the same last name Singh, that is 2 and 3. Contact numbers are unique. However, there is usually a identifier column given to each of these rows. In this case, it's called student ID, which is used to uniquely identify a student. Why is that we don't use contact number as a primary key? It's because 2 students can be from the same household or they can share the same contact number. So that's why we have a generated identifier called as student ID, and that is called as the primary key in this case. Let's look at another table called test results. There are 5 rows and 2 columns. The 2 columns are student ID and test score. The 5th student with ID 5, that is Ronstein, didn't attend the test, so there is no score present. In SQL, in database lingo, we call such blanks as null. Null could mean that it's not available, the score is not available. And if you look at this one here again, it's not mandatory, but it's always a good practice to have an index per table, also called as a primary key. This makes lookup faster. If you consider these 2 tables, here student ID is defined is a primary key for student info table, and test results is actually the child table. In the sense, the student ID, the details about the student is stored here, only the test results are stored here. So student ID here is the foreign key, and as far as this table is concerned, it's the primary key. What a foreign key means is, you can have details or you can have rows in this table test results only as long as they are present inside the parent table or the primary key. That is, you cannot have a test score for student ID 6 because there is no student ID 6 in this parent table, that is student info. So keep those in mind. That's how 2 concepts, primary key and foreign key, differ from one another. A bit more about primary key. Primary key should not be null according to database theory, but in SQLite it's just a bit weird in the sense that they do allow primary keys to contain null, so that is something to keep in mind. Oh, one more thing, we can have more than 1 column as a primary key. When you have more than 1 column as a primary key, the combination is called as a composite primary key. So here is how you can understand the hierarchy of storage of information. Database contains a bunch of tables, schemas, and other metadata or functions. Tables contain row of data, and each row contains columns of information. So if you just look at this one for clarity, database contains student info and test results table. Each table consists of a bunch of rows. A row is made up of a bunch of columns. 4 basic operations involved in the database world are create, for example, creating a new table. Read means looking up information inside a table. Update means you basically change the value of an existing row. For example, you can go ahead and update the contact number for a particular student. That would be an update scenario. And then delete involves removing rows from a table. So in the database world, again, this is called as CRUD. C stands for create, R stands for read, U stands for update, and D stands for delete. So there's one more terminology that I'd like for you to grasp. This one is called as the seek time. That is the time taken to get the hard disk read head above the right track and sector for the read to take place. This is because most of the databases are deployed using the spinny disks, right, which are either 7200 RPM or 58 or 5900 or 5400 RPM. So we need to make sure that this seek time is made good use of. That is, we want to read as much data as possible, but at the same time not too much data. What if we read too much data? It's going to increase the process footprint of our current process that's making use of the SQLite connection. So in SQLite world, the page size is 4 KB or 4 kilobytes. So assume that here, for simplicity, each record or each row occupies 20 bytes and the page size is 80 bytes of worth of data. So here is how the data would be organized on disk. So these are the column names. You can forget this for now. This is just for making sense of what these rows mean. The first 4 rows will be stored on the first page and the next 4 rows will be stored on the second page. Whenever you try to access, even if you want to access the third record, the entire first page will have to be read into memory and then the third record will be fetched. Similarly, when you write, let's assume that there are only 7 records for starters. At this point, since you're trying to make a write for a new record, the SQLite engine will first check to see if there is space in the last page. If so, it will try to add the record and persist it back into the disk. If not, a new page will be created and then the record will be added to the system. That's about it as far as the absolute basics are concerned.